Welcome back. This is an Aleks training video on understanding the definitions of ionization energy and electron affinity. So first of all, let's just give a definition. So if you have ionization energy and electron affinity, okay, so ionization energy is the ease of making a cation. How easy is it to take a neutral atom and turn it into a cation, to a positive? And electron affinity is the ease of making an anion. Okay, so this would be a positive charge and this is a negative charge. How easy is it to make a positive? How easy is it to make a negative? So if you were to take a neutral atom, okay, so let's just say sodium. Okay, so it's neutral. And I want to turn it into a sodium positive, so I want to turn it into a cation, then I have to rip off an electron. So to do that, it's going to require energy. It's going to require energy. For sodium, the first time you rip off an electron, make sure that's an electron. First time you rip off an electron, so we're going to call that the ionization energy of sodium. It's requiring energy 495.8 kilojoules per mole. Okay. So let's look over here just a second. If I were to take sodium, okay, sodium's over here. Sodium has one electron in its outer shell. It's in group 1. If I rip off one, it takes 495 kilojoules for every mole of sodium. It's now going to not have a third row. The third row is going to go away because it only had one in the third row, and if I take that one, it no longer has a third row. It's going to have a configuration equal to neon, which is seriously stable. Very stable. In fact, all elements will react to each other so that they can get a noble gas configuration. Now, it now has in its new outer shell, the one that was inside now is now outside, it has a full octet. It has 2 S's and 6 P's. That's 8. It has 8 electrons. If you are going to steal another electron, if you're going to steal a second electron, it's going to be serious money. It's not going to be $500. It's going to be $5,000. It'll be a lot more energy to steal it because it's stable. All right. So if you have the second ionization energy, so that would be IE2 of sodium, it's going to be 4562 kilojoules per mole. Lots more. So you have the first time you do it, now that would be, what would it look like? It would be Na plus, okay, going to, this is a gas, going to Na2 plus an electron. Okay, that's why it's so much more. You would never see an Na2 plus because to do it, it would no longer be stable, and so it doesn't want to give it away, and if to give it away takes a lot of energy. Okay, now let's say that you're going backwards. Okay, so let's go backwards. Let's say you've got sodium, and I join an electron with it. So sodium with an electron. Well, you're going to get sodium metal back, and the amount of energy that it took to rip off the electron is going to be returned to you. So it would be a releasing of energy. So if it's going backwards and you're getting a sodium metal, sodium metal from a sodium ion and an electron, you're going to get this energy back. So it's almost like a backwards ionization energy. All right. So What's the difference in electron affinity? So if you were to have electron affinity, let's say you have chlorine. So you're going to have chlorine and it's a gas, and you want to add an electron. Okay, because remember, chlorine is in group 7. It wants to be in group 8. It wants to be stable like group 8. So it will steal an electron to do it. So let's say you steal it, right? It's going to dump a lot of energy. In fact, chlorine is the highest electron affinity. It's going to be minus 349 kilojoules for every mole. Okay, it releases that energy. So it's actually very easy for this to happen. And since it's 349 is the highest, that means it's the most likely to gain an electron. It loves gaining electrons. Okay, so the difference of electron affinity is that it's a neutral atom gaining an electron. So whereas backwards ionization is a neutral atom gaining or losing an electron. Now in your example, okay, here's the example from today. All right, so we've got, does the following reaction absorb or release energy? Okay, so it is Ti2 plus gaining an electron. Okay, well, if you are gaining an electron, it releases energy. Okay, that's good. That's easy. So it releases energy. Well, is it possible to calculate the amount of energy absorbed or released by using only the data above? Now, it's giving us a bunch of stuff just to confuse you. We're only really interested in these two. We want electron affinity, okay, which is the ease at which it makes a negative, and we're using ionization energy, which is the ease at which it loses a negative, okay? Well, this is gaining a negative, but it's not electron affinity because it's not a neutral atom gaining an electron. It's a cation. So a cation is just simply going to be paying back for what it ripped off to start with. But this is Ti2, and it's the second ionization energy, and you're not given the second one. You're only given the first. This is the first ionization energy. This is the energy it takes to rip off one electron from a neutral titanium atom. This is a Ti2 or a Ti1 being ripped off, and I don't know what the second one is. Remember, the second one for sodium was a lot bigger, so I have no idea. There's no way for me to know. So I'm just going to say, no, I can't. Okay, and then you don't answer the third question because it was part of the second question. How about number 2? Okay, number 2 says, does the following reaction absorb or release energy? Well, I'm gaining an electron, and if you're gaining an electron, it's going to release energy. That's good. Is it possible to find out how much energy? Yes, it is possible. Why? Okay, well, because if I go backwards, this is Ti. Ti minus an electron will give me Ti plus. That's the first ionization energy. And then if I take it back, it's just a backwards first ionization energy. So 658.8 is how much that I will, in this case, release. 58.8 kilojoules per mole. So I hope that helps you.